Hello everyone, my name is Anubhav Mandal and this task I have done here was assigned to me by GRIP, which is a Sparks Foundation initiative. This basic task is based upon the linear regression, and here we will be predicting the marks of the student based upon the number of hours they have studied. First of all, here we are using Jupyter Notebook, and we will be importing some of the basic Python packages that we use in machine learning. Those are pandas, numpy, matplotlib. Now matplotlib inline would help us to see the graphs within this Jupyter notebook. So the data that we'll be using here is given in this site, and we will be importing this and we'll be reading the data into our variable s underscore data. So s underscore data dot head would give us the first 5 rows of the data set. So from here we can see that we have two columns, those are the hours and the scores. So we can say that scores is a dependent variable upon the hours, right? Now we first need to see that is there any relation between these values, that is the values of hours and the scores. So we are using dot plot function here, and we are giving x, that is the independent variable, as hours, and y, that is the dependent variable, that is scores. So this plot function, from this plot function we are getting this graph. From the graph we can see that this percentage score and hours studied has a linear relationship between them, right? This score is increasing in a somewhat in a linear fashion based upon the hours studied. So we can say that we can fit a line in between these values that can help us predict the values. So that line is the linear regression line. So now what is linear regression? Linear regression is basically a statistical algorithm that helps us to see the relationship, create a relationship between the independent and the dependent values. Now, first of all, we need to divide the data into the two dependent and the independent values, right? So this is the independent values, and this is the dependent value. So we'll be using list comprehension here. That is, uh, this means that we are using all the rows, and this means that all the columns from the starting and up to but not including the minus oneth column. So minus oneth column means this one. This is the minus one. This is the minus two. And if we go from the starting, then this will be the zeroth, and this will be the oneth column. Now, so in this way we can say that this thing will give us x values, that is the hours values, and this one will give us the give us the oneth column, that is the scores values, right, into x. Now we'll be using a method from scikit-learn, that is train test split. Now what train test split does is it divides the data set into two groups. One group we'll be using here for training, and one group will be using here for testing. Now since we are using the training and the testing values, so you can say that this is a supervised model. This is a supervised machine learning, right? So here in the method we can see that we are passing the x values, y values, that is hours and the marks, and then we have two more attributes, those are test size and random state. Now what is test size? Test size is equals to 0.2. That means 20% of the data set will be used for testing the data. Testing size is equals to 0.2, that is 20%, and the other 80% will be given to training the data. Now another attribute is random underscore state. So random state can be null or any other integer values. When it is null, that means every time we run this train test split, it would give us a different set of group. That is, the groups will be different. The size will be same, but the data will be different in both the groups every time. But if it is any integer 0, 1, 2, 3 for a single integer, the data that we always the data that this train test split always gives will be the same, that is the groups will be always different for a single integer. Now we need to train the algorithm. For training the algorithm, we'll be using linear regression from scikit-learn model, and we'll be creating an instance or an object of linear regression. This object will be using all through our code. So first of all we need to fit, that is we are giving it x train and y train in order to create us the line. So for a line, we know that the equation of a line is y equals to mx plus c, that is coefficient into x plus c, that is intercept. So line is the y values, coefficient is the m, and x and c is the intercept. So now we have our line and we'll plot it, right? We'll plot the regression line that we have created from the training model. So these red dots are the values that we have in the data set, and this green line is the regression line that we got from our regressor, right? So we can say that this seems to be a good fit for us. Now we need to show the data that we need to show that this is actually a good fit, so we'll be using calculating the errors and everything now. So first of all, let us make the predictions based upon the other group of data, that is the testing group of data that we have left for until now. So we'll be using regressor.predict in order to predict the y values, that is the marks based upon the x test values based upon the hour studied, right? Now we know that here we are using x underscore test, and we also have a y underscore test that is having the actual values that the student has scored. So we have the predicted values in y underscore predict, and we'll now compare it with the y underscore test. So y underscore test is having the actual values and y underscore predict is having the predicted values. We can see that there are slight differences between the two values, right? Now, even for, when the user is giving us an input, we need to calculate that what would be the marks that the student can get from that, right? So we are giving an input of 9.25. Suppose the user gives a value of 9.25. So from that we are evaluating it into a 2D array, and then we are passing it to the regressor predict. So regressor predict would give us a somewhat nearby score for predicted score for the number of hours studied. So that would be contained in own underscore predict, and we'll print it. So the number of hours is 9.25, and the predicted score by our algorithm is 93.69, right? Now to show that what are the differences or what are the errors in between, we can use the absolute error. Now what is absolute error? Absolute error actually gives us the differences between all the test and predicted values. So we can see here absolute error is y underscore test comma y underscore predict, that is giving all the differences between them, and mean is means of the mean of all the absolute errors, right? So from the algorithm that we are using, we are getting a mean absolute error of 4.18. So I hope I was able to clear this basic task based upon the linear regression.